Alright. Yeah, I gotta do a little bit more. But yeah, it works. So I need a little bit more cleanup and things. But I actually have an engine that works. It doesn't need the flywheel. I'm gonna run out of air here in a minute. Pretty awesome. So another successful motor. Huh. So what do you think, guys? Pretty cool, pretty cool. 8 weeks worth of work to make this guy. A lot of fun, a lot of frustration, because again, I was learning as I go, trying to figure out what counts and what doesn't count. So here's the print. If anybody wants to try making it, come on, get the 2 pieces of paper apart. Oh well, there, finally. So there's the print. My email is always at the end of every video. And what? So I'll be here to help if anybody has questions or problems or tries to make one. But made a little stand for it, and I was thinking about putting this on the laser CNC and burning a date or something in it. But fun, it works. And I just put this thing in the bandsaw and just cut it off because I can't grind it. I don't have a way of holding it yet. So something that small or short, really. So okay. Oh yeah, this is the final episode, and I'm going to talk about each part one at a time and explain what counts, what doesn't count, and so on. So on with the show. Alright, I wanted to get close in so you can actually see the print and the parts. And I want to talk about one item at a time, because if you download the print from the internet, it doesn't really give you any heads up as to what's important and what's not, as far as dimensions or how this thing goes together. So, you know, I did all kinds of pictures so you can see what's going on. First part I made was the crankcase cover here, and hindsight on these holes that you do, I've got a radius on them. Whatever technique you use to do the holes, use it on every place on the engine. You know, I've got the same hole pattern in the cover, in the engine crankcase, and in the back cover, and so on. I use the touch DRO or the radius function, and I just now realized, looking at some of these numbers, 32 bits pretty tight for a 440 hole, so I'm increasing it in size to 31. So the dimensions out here obviously are not critical. You can have this as thick as you want and the outside at any diameter you want. So that's not critical. What is critical is how this shaft works. I'm using a piece of 1144, and it happens to be exactly a 1/4 inch. So you have to ream this. You want the shaft to not wiggle, move, or anything at all. And you definitely have to have it on center throughout the engine, because this shaft is going to have a pin here on a crankshaft, which has got to line up with this one, this thing over here, the valve crank, perfectly. So you want this dimension right here, and I just changed it because I'm looking at the other print going, the other print for the crankcase, this opening is 1.156. So if this is 1.156 from here to here, then you're going to be a real snug fit. So that's the important dimension, is you want this guy to fit in the crankcase perfectly. No little place, so you know your shaft is centered. You want enough of material here so that it keeps the crankshaft from wobbling. The depth of this too, this dimension, is critical, because you're going to have an entire stack up inside the crankcase. And when you're assembling it, you only want a few thou of gap between everything. I don't know if you can see, this is how much play I've got inside. That's probably 20, maybe 30 thou, so that it turns easy. That's the other biggest thing for this engine to run, is this has to turn really easy. So as you're making each part, pay attention to the surfaces. This needs to be a nice, smooth, slick surface. Lap it if necessary, whatever you got to do, because this guy is going to be, who's rubbing on it? Oh, the back side of the crankshaft here is going to be sliding on this surface right here. So I think that's all I can say about this particular part. Again, I know I'm repeating myself a lot. The chuck stop, chuck spider is necessary. You're not going to be able to get anything this thin in a chuck to be able to machine these parts. What did I do? I forgot what it was. I think this is 1.5 inch. Turned the outside, did the face, did this face here, then flipped it around and grabbed it and machined the other side. Then this went in the mill because I wanted to make sure with the edge finder I was dead center drilling this hole. And I also did these holes in the mill too, touched the RO. Alright, now I'm going to talk about the crankshaft itself, making it. Yeah, I had a little piece of 1144, 1/4 inch. Turns out it was exactly a 1/4 inch, so it fit the reamed hole in the cover, front cover, nicely. Still has the black on it. I did try Scotch-Briting it, but then the shaft got real sloppy, so I had to cut another piece off to use as the crankshaft. This guy is a critical dimension, and I'll explain how to compensate for it later. Try to hit the dimensions on the money. If you mess up and it's too big by a few thou or too small by a few thou, I'll explain later how to compensate for that. But that dimension is critical. The location of this hole is critical, and centering this up. The outside isn't, because this is just sitting in the crankshaft. Big, lot of clearance on the sides to the crankcase. So you don't care about this dimension. I believe I just used a 1 inch piece in the chuck, turn the outside, face it, cut it off, turn it around, face the other side, trying to hit the dimension. Then, like I said before, you got to watch out. This surface is running on the inside of the crankcase cover. So I lapped one side of it, so it was slicker than all get out. I actually lapped both sides, and I'll explain why you need both sides later. In the mill, wanted to make sure dead center, and this is on this in the exact correct spot, because it's got to line up with this guy over here. 1/8 inch brass. This was just press fit in, and this was reamed. I forgot to put in there that, so I got to add it to the print. And then I used Loctite 232, which is non-permanent, to hold this guy in position. The face of this I took to the tool grinder and just cleaned up the edge, so it's just beautiful on the edge of it. It looks like it's been ground. Well, it was ground, but... So, what else to say on this guy? Yeah, you gotta be smooth, and everything's gotta fit perfectly, all the dimensions. This is the only one you don't care about. The length of this, it does have give, because it's gonna go through this, but you have some, the dimension is critical, because you don't want it to hit the face of the crankcase here. This is going to go in the crankcase, so you want it to be just shy of hitting the face. So, and again, all these dimensions I'll explain later here in another segment. on how to compensate for errors in this and how to compensate for problems with this. Anything else to say on this? Not much, really. Okay. Yeah, looking in the camera, looks like you can see this, but I'll talk about this part. This goes over here. Part I just talked about, the crank shaft. Again, there's the surface here, and it's going to ride on a surface here, so both sides are lapped smooth. This guy is the valve crank, and the surface here has to be really slick on both sides. So I can't remember how I machined this. I probably had a chunk of 1 inch. Again, the outside doesn't make a difference. There's a lot of clearance here. So 1 inch, I turned it, faced it, cut it off, probably, yeah, and then I would have flipped it around and turned this part. So, and then I know I somehow lapped and got this real fine. Didn't have to worry about undercutting this corner because you're going to chamfer this right here. So if there's a shelf or an angle in here, you don't have to worry about it because you're chamfering the crankcase and it'll clear it. The length of this is critical to a degree. It doesn't come flush, so this dimension is not super critical. You can mess up a bit. This guy, again, you can mess up on this, and I guess I'll explain now why, but if you're off on this, fine, whatever it is. This hole has to be right on the edge. I never gave it dimension. The original print gives a distance from the center out, but I swear it was the drill bit was going to break out the side. So I had made one wrong, which you can look at here. You can see I drilled here instead of here. And it is important because this guy is going to be controlling where the pistons are. This is controlling where the air goes into which cylinder. So I had to remake this guy. So hole placement is important. This is critical here because it's going to line up with the crankshaft. And I have actually oversized this hole slightly to allow for some kind of misalignment with the crankshaft. This is critical because you're going to ream out the crankcase. Did I put that note in here? I gotta check the other print. You're gonna ream out the crankcase, so this has to fit in there really nice and no slop, no play. And okay, on the thicknesses, if you mess up, you can see this whole thing's a stack. So if you made this this thicker, make this thinner or whatever. But the final part is this guy, the connecting rod hub. Whatever dimensions you do here is what's going to control your stack up and how much play you're going to have in here. So you might, you know, caliper this guy, caliper your crankshaft, and then actually measure the depth, what you bored out in the crankcase, and then you need to come up with like 20 thou or something play in here. So that's how you can compensate for errors and things like that. It's down to whatever the last part is you make. The connecting rod hub is, I had problems with it. It seemed like it was going to be easy. It's brass. I never wrote here brass. Okay, I'm starting to catch things still. Brass, it was pretty easy to make, but on all these parts I did hit the tolerances or the dimensions, so everything stacked up nicely. This dimension doesn't matter, and again, all these don't. Well, this one does, because when I made the connecting rods, I made them snug fit, and you can't do that. They have to flop freely. Here's one right here. They have to flop really freely in there. And I wound up buying a 93 thousandths gauge pin. Well, yeah, I did a drill bit. I don't have a 3/32 reamer. So whatever size the hole was, I bought the gauge pin to go with it. One gauge pin, cut it into 3 pieces, ground it, and drops right in there perfectly. So it's flush and the pins are super smooth because they're going to be riding on these surfaces here. And again, do I have the radius here? Yeah, I do. 437 radius. That one isn't too critical. I don't know why I didn't call it a radius, but okay. I may change this print to call it a radius. This dimension isn't too critical. It can be off by quite a bit, but the connecting rods. The other, now 2 things were, one, I had a tight fit, so the engine wouldn't run. One of them actually bound, or whatever, it was just stuck at an extreme. The other question I had was, are these things supposed to be flopping all around like this? The video that I referenced, the guy soldered one of the pins in place, and I have a feeling he locked it up, but never came back to talk about any of this, how he got this together. Because there's no way you're going to be able to assemble this outside the motor and get it in. I put one con rod in it with the pin, and you can angle it, get the piston through an opening, and then get this thing in there. The rest of them, you have to, in a very tight area, put the other rods in and drop the pin in there. And boy, it's not fun because they're tight fit. This, again, 3/32, whatever the hole was, the pin fits it, and I used the same drill bit to drill the holes on the con rod. So everybody was a perfect fit. Again, make sure you're skinnier than whatever dimension is you did here, so that it moves really easy in there. And yes, they are supposed to go completely, like, to hit the center all the way around. I think that's everything that was critical on it. The stack is important. Reducing friction is important. Good fits, you know, no sloppy stuff or whatever like that is incredibly important on this. Okay, now talking about the cylinder. And this is where I really got myself into trouble, and I'll explain what happened. But first of all, not outside dimension, yeah, not critical. I think I said I wanted round. Original print had square cylinders. So I used a 1 1/4 piece, turned the outside, and then groove it. And here's all the dimensions on the groove. I didn't specify how deep, though. I went into the groove. The original print called out a 5/8 piston, and I didn't have a 5/8 reamer, so I changed the design to 1/2 inch, and that's what got me into trouble. How to explain then? First of all, I didn't explain very well about getting a perfect cylinder here. If you're going to bore this out in the lathe, you're going to go in with a boring tool, and what's going to happen is if your compound's slightly tilted, you're going to wind up making a funnel. So you can't do that. I did that with the flame liquor, and yeah, all kinds of problems in trying to lap it straight. If you're going to do it with a boring tool on the mill, you're going to, what happens is, as you go down in with the boring head, your gib is doing this number. They're not perfect on a mini mill. So you wind up with ridges. So again, a problem. You have to use a reamer. And this was my first time using a reamer, and it came out beautiful. But I changed the design from 5/8 to 1/2 inch, and I didn't have to, and I don't know where I went wrong in CAD. But I've said before, never start building something by the seat, flying by the seat of your pants. So I was doing a lot of CAD work, putting down every dimension trying to figure out how this thing went together, what was important, what was not important. So I wound up reaming this out. Perfect, beautiful, nice walls and stuff. Didn't have to lap anything. Didn't do anything. Then I made the con rod, piston rod, based upon their print. It was more square and it was all the dimensions that they called out. And then when I finally put this thing together, it was hitting. It was hitting the piston right here. So, and I flip it around. This is where it is. I didn't realize how far it was going to have to pivot, and it was impacting here. So I wound up shortening the piston down to a 1/2 inch from what the original print said. So now it was clearing it. It could go far enough. But then the next thing was it was hitting here on the cylinder. And so I'm going, okay, this is getting irritating. So now what I did was I just put this back in the lathe and faced it off and brought this down to 100 thousandths. Put it together. It's still hitting it. So now I'm taking an end mill in there and I'm just taking a chunk out of it, both sides. Kind of eyeball where this hole is and say, okay, this is probably both sides, and a big end mill and taking a chunk out of it. So now I'm clearing finally that. The next thing was, okay, now it's hitting over here. It's hitting on these things. I don't know how to draw it really, but if that's the face, you're going to have the hole like this, but then you're going to have a high spot. So I had to put the engine blocker, the crankcase, back in the mill on a 60-degree V block so I could run an end mill down in here and tear this whole sidewall out. Finally, I could rotate the shaft and it wouldn't hit anything. So that's where I got myself in trouble. Turns out, yeah, 635,000, I could have made it. I don't know why I didn't see it doing the CAD. I had plenty of clearance for the screws and the grooves and the whole, well, the grooves don't even go into the screws, but 625, there would have been plenty of meat on the side and I wouldn't have wound up in this problem. Oh, the other thing I tried to do, I said, okay, see if I can make them round, and for some stupid reason I put the small end in and tried to file it round. Why I didn't grab the meatier end, I have no clue. So what's in there now is round piston rods. I had to make a whole new set on the rotary table, 160 thou diameter, and after I made that it was still hitting. So that's when I think it cleared this. I didn't have to do that, but it was hitting here, so I had to come back in and tear this whole sidewall out with a very long end mill. So what is critical here then? The length is, because that's your stroke of the piston, how far it moves. That the dimension here matches your piston. You got oil grooves in there. And I'm just using oil, light motor oil in there right now. That works fine. All of these dimensions here, excuse me, are pretty critical. Ream, and I made a brass pin in there and rounded the edges so that it's rounded. And what, something about when I did this on the lathe, faced the ends off, left a burr, which I left on there because when I pushed this in there, it jammed it in position. So the pin actually like goes from here to here. It doesn't actually come out to touch or score up the cylinder wall. So that's what I did with the pin. These guys, the grooves, I'm using oil. This dimension probably isn't super critical. What else here? Okay, this dimension's not critical. I did increase the drill size here so that I had plenty of clearance. This dimension from here to here is critical. Is that on this print? No. Oh, well, you're going to get it from the crankcase. Whatever, you bored it out, so you want it to fit in nicely. This whole placement, this is the air path here. That is critical. And here. These are the faces, the 3 faces to the crankcase. So that has to line up here, right there, because the air comes up and goes through. And then I showed already how I made this little groove here so that the air goes in this hole, goes up through this hole, goes through here and over here and into the cylinder. So that's the air inlet and then the outlet, the exhaust. Oh boy, anybody else? Yeah, you can see them here. So there's the dimension to make everything line up. It has to be on center too of the cylinder. Was there anybody else I said had to be reamed? I did say that has to be perfect. That has to be perfect. Well, that has to match that and jam in there. All these holes too. I've explained the 3/32 drill bit, whatever. I did have a 1/8 reamer, so I should say ream here. Did I ream? Yeah, I did ream that. Okay. So I'm missing a dimension here. The cylinder caps, really easy, no brainer. Again, yeah, you do need that chuck stop or the spider because it's only 125 thou thick. And so I would say if you're going to make it, use all the dimensions. I don't know, I haven't done it to the print, the 5/8 pistons. But if you're going to do it, you definitely have to ream it. And that's the only way. I just learned how to get a really nice cylinder. And then you can easily make the piston match it pretty nice and snug. Did I say... Oh, I haven't said what to bore it out to, huh? Yeah, I don't know. This dimension here, yeah. I probably should give it some tolerance in here. Yeah, I don't have... Well, I'll look at it off camera to see if I'm missing this size. 440s, okay. So that's kind of everything, I guess, into putting this in, or building this engine and putting it together. Kept playing with this length of these things, so you guys probably just double check me on that. So I didn't mention too, the other print shows the hole pattern, but you got to pay attention, because if you're going to do this inlet and a flat spot, you want to make sure it's facing up on some surface and not into a piston or something. So you got to pay attention to where you put the holes. And I remember on it I said 30 degrees, start the hole at 30 degrees. And the touch DRO, you can enter in where you want the first hole to start. So if you're going to build it, have fun. This is going to be a hard one to explain, but I'm going to talk about what this valve crank, the valve, and the valve cover here on the back of the engine does. This is the stack up here. This is the cover, the valve, and then of course the body. This the valve crank, the pin that comes out of here, is going to go on the center of the valve. So the valve's going to be spinning in an elliptical manner. So what happens is, and this is the correct orientation for this valve too, what happens is the air is going to come in the back. It's going to enter this chamber, this part here, and the air will go through these 4 holes. As this spins around, you'll remember there's 3 holes, one for each cylinder on the back side of the crankcase. As this guy covers a hole, air goes into the cylinder, compressing it, the piston goes down, causing this thing to move, which then causes this to cover another hole and release the hole that it was just over. That hole now becomes the exhaust. So as you're pushing down the next cylinder, the previous cylinder is going up, so this is the exhaust, and it's entering this chamber and going out. So that's basically what's going on. You're spinning around over 3 holes and you're compressing one cylinder and letting the next one exhaust. So as you can tell, this is going to be really critical. That's why there's little grease grooves on both sides. This has to sit in here perfectly. So what I did was I machined this and I made it a few thousandths thicker, probably 1 thou or something like that, and I machined this in the mill, and I showed making it here in a previous video with an end mill. You got to make sure that this is absolutely parallel, I guess you'd say, to these surfaces. You can't have this surface crooked because it's not going to spin right. So what I did was I put the screws in here lightly. I had, I think it was 2 micron diamond paste on both sides. And I ran the drill bit on the crankshaft. So this thing was spinning around, lapping itself in. And then I tighten the screws a little more and spin it until I got a perfect seal between this face and this face. So the outside dimensions don't matter. The depth of this thing is why I have plus or minus 1 thou here, and same way on this guy. The inside dimension doesn't matter either because this thing is just spinning around with lots of gap on both sides. Same way, you know, well, that I'm saying the outside doesn't matter, all that job. So that's probably all I can say on this because they never really said which way this valve goes in. So this is the orientation, and I have it right now, and you can see it running. And that's why this hole has to be a very good fit, because you don't want air leaking into the crankcase. This whole compartment has to be airtight against this face so that it works with the cylinders. Last but not least, this was actually the first part I made, was the crankcase. And it was pretty easy. I had a 2-inch rod, aluminum rod, put it in the chuck, turn the outside, face it, flip it over, face the other side so that you're at the correct depth. Now, this is the fun part. Now you got to move it over to the oh no, before you take it out, drill the center hole. Doesn't matter what size, you're not going to ream it yet, but you want a reference point for when you're in the mill as to where the center, absolute center is of this cylinder. Now you can move it over to the mill, put it in the vise, you can edge find off this center. Do your hole pattern, which is right here. Tap 656 radius, tap those holes, and then drill these 3 holes that you're going to go through the 280 thick wall, so you don't have to go all the way through. So now what you do, and it's pretty easy, you put 2 screws in all the way, tighten them down. Now you can set this thing on a parallel in the vise. So you have now this surface that you're going to do reference to these 2 screws. Mill it off, rotate, you know, move the screws, do it again, and so you got 3 surfaces done. And if you think about it, these 3 surfaces don't make any difference. So they don't have to be exactly the same. But you're taking this down so that it's to a point where you're happy with the cylinder fitting on top of it. Did I call out here someplace a face? Yeah, I did here. 1.650 you want it to be across. So. And you'll have to redo the math once you've got 3 surfaces, because now you're not. You're still sitting on the screws. So it'll be the same depth of cut every single time. Once you have that done, when you flip it over, now you have the hole to reference on and the edges, the faces, to do this screw pattern. So, and then you can finally just bore it out to the depth here. That's 970. So till it's about 280 thick in here. And then, you know, too, that's why you measured this depth to do your whole stack up to make things correct. But yeah, this shows the valve housing on the back and then the little air hole going up into the cylinder. These 3 holes here. I just show one of them. So that's how I did the crankcase. It was pretty easy. And you can actually go further if you want, but you can see I just kind of quit so that I left a little bit of meat. Actually, I can probably tell you this side is thicker than this side. What you don't do and don't care about is you don't care if you're slightly off in the V-block, because the piston rod will allow the piston to tilt. And it doesn't matter if you're not going straight up and down or you're going at an angle slightly. What you care about is you don't want this thing to tilt this way, because the pin that's in the piston is not going to let the rod do that number unless you made the hole real sloppy, which is not a good idea. So 3 faces you don't care about. The other 3 faces you want to have them absolutely straight, but you did machine both sides, so when you clamp it in the vise sitting on the 2 screws, you know it's going to square itself up perfectly. If you're in doubt, you can always put a round rod on this side, so you know this face is squared up against the vise jaw.